Hello everybody and welcome to yet another math video. In this video, I'm continuing and finishing notes for assignment 21 in my ABS class, and we'll go over what it means to set up using the simplex method. And basically, you want to do everything like in the last example, but we're going to stop after finding the pivot and the entering and exiting variables. So this example will take significantly small amount of time compared to the last one. Let's jump in. First thing, most important thing you should do when you're given an example or an exercise, don't worry about the periphery stuff. We'll get to that in a minute. We need to read it. First things first. You're making fruit baskets with oranges, bananas, and apples. The table gives the amount of fruit required for the two arrangements. Each day you have 240 oranges, 270 bananas, and 320 apples. Arrangement A earns a profit of $10 per basket, and arrangement B earns $8 per basket. How many of each basket should you make per day to maximize your profit? Reading the entire example gives you the best idea as to what your variables are. Your variables are basically what's being asked of you. How many of this do we need in order to maximize the profit? And in this case, we have arrangements. So we have x sub 1, we can say the number of arrangement A, and x sub 2, the number of arrangement B. So remember, that's the first thing you're going to want to do every time is define your variables. The second thing you'll want to do, and I think it's pretty simple in this one, is you want to find your objective function. What are you maximizing? What are you minimizing? And we're trying to maximize profit. So then we look through this example and see if we can find anything about profit. So here, arrangement A earns you $10 profit, arrangement B earns you $8 profit. So to write down the objective function, we would say the profit would be 10 times x sub 1 plus 8 times x sub 2. The third thing that needs to happen here then is your inequalities. So the inequalities will be based in these variables here. And I don't necessarily see a whole lot of other information in this paragraph here. Except for that we have 240 oranges, 270 bananas, and 320 apples available each day. But that's where the table comes into play. We know exactly how many apples, oranges, and bananas are used in each arrangement. So let's use that to our advantage. We can have an apples inequality. So I'm just going to write apples here. We can have an oranges inequality, and we can have a banana inequality. So from here, we know that apples, down here in the bottom row, each arrangement A uses 8 and each arrangement B uses 6. So we'll have 8x sub 1 plus 6x sub 2, and there are 320 apples available daily, up to 300. We can't go above that. So we have to be less than 320 or equal. If you end up using less than 320 apples, you can have a healthy snack for that day. Let's see, for oranges, arrangement A uses 4 of them. Arrangement B uses 6 of them. And for oranges, there are 240 available. For bananas, again, it's going to be very similar. Each arrangement uses 6 bananas here. And we're allowed to go up to 270 bananas each day. So now I'm going to scroll this up and create the E system here. So the E system is based on the inequalities that you have. I'm forgetting here. Definitely need to have x sub 1, x sub 2 greater than or equal to 0. Okay, now the E system, we don't use either of those inequalities. but we will use all of these other inequalities here and the objective function. So the E system will look something like this. Okay, here it is. Again, the first inequality here, we would add a slack variable and set it equal to 320. The second inequality here, we would add a different slack variable, hence the 2, sub 2, set it equal to 240. The third inequality, S sub 3, would equal 270. And then the last equation would be this profit equation. Remember, we want a positive p-value. The only other thing left to do here is to change this into an actual matrix. So here we go. The matrix will look something like this. We know that there is going to be a column for each different variable. So there's x sub 1, x sub 2, s sub 1, s sub 2, s sub 3, and p. So let's write down each of these. Let's see, this would be 8x sub 1 plus 6s sub 2 plus 1s sub 1 equals 320. All the rest of these are zeros. The second equation, we have 4x sub 1, we have 6x sub 2, no s sub 1s, 1s sub 2, 240. The rest of these are zeros. Let's see, we have 6x sub 1, 6x sub 2, 1s sub 3, and 270. The rest of these are zeros. And finally, in the last row, negative 10x sub 1, negative 8x sub 2, 0, 0, 0, 1, 0. All right, there's the matrix. Now, what will the labels be on the left side here? The labels are always going to be the slack variables in P. They will always start there. So the slack variable 1, slack variable 2, slack variable 3, and P. All right. The only other thing we have to do now is find the pivot position. And the pivot position, again, is based on the most negative number in the bottom row. It's going to be negative 10. So I'm looking at this column here. And we just have to go through and figure out the divisions of the ending numbers here divided by the numbers in that column. So 270 divided by 6 is 45. 240 divided by 4 is 60. And 320 divided by 8 is 40. We pick the smallest one of those. The pivot element in this example is here, the 8. And again, if you go straight up, you'll know the entering variable, so x1 will enter. And if you go straight left from that pivot element, the exiting variable will be s1. And that's it. That's all we have to do for this one is set up. And set up just means go through all the way until you find the pivot, which we did, and the entering and exiting variable. Much quicker example just for the setup. I very much hope that this makes sense for everyone out there. And as always, good luck.